Okay, good morning all. Thank you all for coming. Welcome to the MySQL User Conference. My name is Roland Bouman, and I'm going to talk to you together with Matt Casters from Pentaho Corporation about data warehousing. I decided to put together a presentation. We're actually trying to scratch the tip of the iceberg and try to explain to you in 45 minutes what data warehousing is. And I'm doing this because I noticed that many people in the MySQL community talk about data warehousing. Basically, they're talking about a big database. Well, there are a few concepts regarding data warehousing, business intelligence, and I was just hoping to clarify a few of the concepts and also, in the end, to show you what it all means and what you actually can do with it. Okay. So, anybody here doing data warehousing at home? Okay. Okay. Anybody familiar with the Sakila schema? Sakila sample database? Okay, that's not a whole lot. But, the idea is that the Sakila is a sample database which is available on the MySQL download site. It's a very simple schema, and we decided to show how data warehousing would apply to this particular sample database. Okay, so here we go. There are a few terms which are related but distinct. You've got business intelligence, data warehousing, a dimensional model, star schemas, data marts, and OLAP databases. And these concepts tend to be blurred in discussion, and we're trying to clarify what it all means. So what is business intelligence? Well, basically, business intelligence is a very broad term which knows almost everything that you use to gather information to learn more about performance of your business, and everything that you do to understand more about your business in its environment, and hopefully to manage that better and to perhaps predict performance in the future and have better control of your business to make more money, do things more efficient, that kind of thing. So that's business intelligence. So what's data warehousing? Data warehousing is, well, it's nothing more than simply a database which is especially designed to perform business intelligence. That's all there is to it. So, in the end, it's just a relational database, just like any other database. It's got tables, it's got columns, all that kind of things. But the difference is in the design of the model and the design of the schema, because that's designed for ease of use and for performance, especially for business intelligence applications. And one of the characteristics is that you use data warehouse to gather information from multiple data sources and bring it together and make sure that you have everything nicely in one place, so that you can make reports across systems, right? So, as an example, if you perhaps have an H&R system and you have customers in there or employees in there, and perhaps you have a sales system and you have your employees in there, that's different systems. It's hard to make reports that make sure that the same definition for this employee is it's used everywhere in your report. So that's why you can use a data warehouse to bring all this data together and make sure you're talking about the same thing, that your definitions are consistent. So, if you look at the pieces, then the data warehouse is, some people talk about just the database itself as a data warehouse. Some people also include all the structures around it that you use to fill the data warehouse and actually to present the data to the applications. So there's a couple of different notions of what a data warehouse is, but there's always one part involved, which is a database which contains all your data you use to provide this information to manage your business. So, what are the differences with regular databases? The Sakila schema is a typical OLAP database. It's a typical schema designed for online transactional processing, which means that it's suitable for entering new customers, for entering new DVDs, and for maintaining the rentals on a daily basis or an order-by-order basis. And with OLAP it's different. The typical business intelligence applications are OLAP applications, and which means that you're not interested in individual cases usually. You're more interested in the sales for a particular month, or for a whole year, or for one particular branch. So the entities on which you're looking is is much larger. And typically you're not interested in individual details of orders, but you're interested in counts and sums and averages. So it's a different way of looking at things than the OLAP way. There are a few characteristics. You can see that OLTP systems they have to be always on, right? If you can't process any orders, you're obviously in big problem. Whereas with OLAP, it's more on the time scale is larger. You're talking about, supporting tactical, strategic decisions rather than making sure customers get their goods delivered. So it's a different granularity of business. Okay. Another very important thing about OLAP databases is that they maintain a history over all time. So if you look in the Sakila schema itself, you will see a few timestamps which indicate when something has changed, but you cannot look back in time. You cannot see what the customers look like a year ago, where they lived a year ago. You just see a snapshot of the now. And in all applications, different. You can look back and browse the history, what happened to everything and everybody. You can also see it in the OLTP database. It's more, it's very subject-oriented. You're talking about individual entities like films. You're talking about employees and stores. Whereas in OLAP, you're talking about groups. Like you're talking about one business process and all the different ways that you can view this same business process in. And we'll see a few more examples of that later on. Okay. So, and then in order to support this different kind of application, you need a different organization in the schema. And that's where you see a lot of big differences. OLTP databases are usually designed using entity relationship modeling. And you're talking about entities and the relationships. You're using foreign keys to enforce those relationships and indexes in your schema to make certain searches faster. And in OLAP, you see a different kind of model. You're not talking about relationship models, but you're talking about a dimensional model, which consists of just a few things of facts and dimensions, and the dimensions are organized according to hierarchies. Usually you do not enforce referential integrity in these schemas with foreign key constraints because you take the data from source, from OLTP systems, and make sure that you load the data in such a way that the integrity is maintained anyway. So you don't need foreign key constraints to enforce all that stuff. Another thing is that in many cases, to answer typical BI questions, indexes may not make as much sense or may make sense in a different way than an OLTP database, because a lot of problems are solved by simply scanning a large portion of a fact table, and in which case you don't have a lot of use for indexes. Okay. So what is this dimensional model? Well, basically it's still a relational database model, but it characterizes tables in two kinds of tables. You're looking at facts and dimensions. So facts are the tables fact data are measures or metrics of a business process. And examples are, for example, the cost or the amount of sales or the profit. Those are typical metrics. Usually numerical values which you can add according to a number of different aspects. And those aspects are dimensions. So whenever you have some business process and you ask yourself who did it, what happened, where did it happen, when did it happen, those are typical dimensions. So you can use those dimensions to slice up the metric data and learn something more about the context in which your business process happens. So if you're talking about, for example, sales, then something like the profit would be a typical sales metric, and the dimensions which you would use to look into this metric would be when was something sold, in which store was it sold, who bought it, what customer was it. So those are the different things you're dealing with in a OLTP database. To make it a little bit more tangible, I've created a little cross tab which shows you exactly how this relates to each other. And what we see here is we see along the axis of this cross table, we see two dimensions. we see on the horizontal axis we see time, when did it happen, and on the vertical axis we see location, where did it happen. And in the matrix itself we see the actual numbers, the actual metrics, and in this case it's the sum of sales which happened. There's another aspect about these dimensions you're seeing here, because the dimensions are divided or organized in hierarchies. So along the horizontal axis we see time, and on the far top we see the quarter. But the quarter itself can be divided in individual months, right? And you see that you can not only see the individual months, but you can also see the total for all of these months. The same applies to the vertical axis, to the location. We see at the far left we see the continent, and then we see a division in smaller parts. Right, so that's again hierarchies. So how does this translate to table structures? Usually you see that fact tables contain a number of measures. So for example, if you're collecting facts about the sales process, you can collect a metric such as profit, another metric would be cost, and another metric would be amounts sold. So these are all metrics which are at the same, apply at the same level. Apart from these metrics, the fact tables will have keys to look up the dimension which applies to that particular fact. Right? So the measures will be usually numeric things which you can add across dimensions. So this means simply that if I have sold 2 items in a store in North America, and I sold 2 items in a store in South America, I can easily add them up and look at all stores, and I will find that I have 4 items sold. This adds up. That's what I mean by additive. Another characteristic of these fact tables is that they're rapidly growing, because every time you complete an instance of the business process, you will get new data flowing in, new metrics, and these metrics will be divided again across these dimensions. Dimension table structure is usually these will not contain numerical metrics, but they will contain descriptive attributes which you can use to slice up the facts. They are relatively small in comparison to the fact tables, and they're relatively static in the sense that they don't grow so much and they don't change so much. And there are a few exceptions, but this will probably go too far to explain in detail. Another thing that you use these dimensions for in BI applications is business users use it to filter data. So if I'm the manager of a particular district or a particular region, and I can use these metrics to find my region and look only at the facts that apply that are under my responsibility. And I can then use the hierarchies to find interesting pieces of data. So if I'm looking at one big region like North America, I can then use the hierarchies according to which this dimension is organized to drill down and to look at, for example, why is Alabama renting so little DVDs in comparison to California, something like that. Okay. So let's see how this applies to a concrete example. In this case, we take the MySQL sample database of Sakila. It is about a DVD rental business, and it's a typical OLAP database. So this is the entire schema of the Sakila database. And what we see here is I use colors to highlight a certain aspect, or actually a certain object. So in pink we see everything that has to do with films, and in purple we see everything that has to do with location and addresses. We see in green everything that has to do with stores, so store staff and store inventory. And away at the bottom we see everything that has to do with customers. Okay, well, if we would flip forward real fast and create a data warehouse structure out of this, then typically you would end up with something like this. And you see the structure is very different. One of the big differences is that here we see a lot of relationships which connect the entities with each other. And we see that the tables themselves are relatively small in terms of the number of columns. A few columns, a lot of relationships, And this type of model is completely optimized for maintaining data, maintaining rapidly changing data. Whereas the star schema we see over here, the data warehouse schema, is, well, relatively few tables with a lot of columns, a lot of columns. And way in the middle, there's this fact table, which just has a few metrics and keys to the dimension tables. And you can see that there are no interconnections between the dimension tables, right? We only see relationships from the center to the outside, to the periphery. Okay, so how does this work? What you see here is a simplified version of the original Sakila schema, and this is a simplified version of the star schema we saw afterwards. And I just want to highlight again that the dimension tables we used are there to tell you something about when something happened, where it happened, what happened, and who did it. Okay. So, star schema is just a physical implementation of this dimensional model. It's called a star because, well, you can see it's star-like. Star schema is just an implementation to allow this dimensional way of looking at things. And you can also do it in a different way, which is called snowflaking, which I won't cover much further. Okay, so suppose you want to create a star, you want to create this database schema. What you would do is you would select some business process, you would define which facts are characteristic for this business process, and then you would figure out which dimensions you would need to look at this business process. Okay. So in this case, we're going to take the business process rentals. We're going to identify a few key facts. In this case, the count, the number of items, and the rental duration. And then we're going to choose dimensions. And then you can see that the what are we renting? We're renting films. When are we renting it? We're recording returns and rental dates. Who is actually involved in this business process? Well, there's two parties: the customer, who is renting something, and the employee, who is renting it out. And then you have the where component, which is identified with a store dimension. So first what we do is we start with this fact. The fact is what we look at. And this first part is very much the same as the original Sakila schema. We have the rental table, and it points to an inventory table, staff table, and a customer table. And if we take the relationships one level further, then you can see that inventory and staff both point to store, and inventory also points to fill. Well, this is where you see all these interrelationships that we want to get rid of, because they prevent us from looking to the data in a dimensional way. They prevent us from slicing and dicing the data up. So what we do is we're going to remove structures here, and we're going to basically take the columns out of these tables we're going to remove. We're going to remove them and place them in other tables. So this is a process of denormalization. We have here a normalized database still, and now we're going to fold columns into the other tables and denormalize it. So, and here you can see immediately that we're duplicating data, right? Because you can see that right now staff is pointing to store, but rental is also pointing to store. So we're duplicating the store data. And for the category used to be intersection table between film and category, and we folded the different categories into our film table. So that's another way of denormalization. Next level, we find that store, both stores actually, and the customers point to address. Well, that's again something we want to get rid of. Whenever you see relationships pointing to the same table in your normalized schema, then you can make a dimensional structure out of it by breaking up the common entity and folding the columns back into the tables that are pointing to it. So in this case too, we're getting rid of address, and we're folding the address columns into the customer and the store tables. So we can repeat this process for a bit, and finally we end up with a few dimension tables containing columns from all the different tables, from all the different related tables in our original OLAP schema. So there's something missing in this schema, right? Because we covered what are we renting in the film, dimension. We covered where we were renting it from, which is the store dimension. We covered who was renting it, the staff and the customers. And what we're missing is, well, anybody knows what's missing? When, right, correct. So in the other cases we saw that we are actually folding tables into dimensions. And in this particular case we're looking at one attribute of the rental table, namely date. And date itself can be extracted from the rentals and created into a different dimension. So and we're actually looking at two different aspects of that because we're looking at date and time. And this may be hard to grok the first time when you're looking at, well, the data type contains both the date fields and the time fields. But in a typical data warehouse you would actually break it up into two dimension tables, date and time. And the reason is that the date dimension will be used by business users to look at interesting periods over the year, right? How are the sales or how are the rentals in Christmas as compared to Christmas this year as compared to Christmas last year, that kind of thing. Whereas time is more interesting in the sense of what are the busiest hours during the day. And you will rarely find the need for a report that combines the time and the date data in one, in one kind of overview, which is why you break it up in two different dimension tables. Okay. And actually when you look at it, we have multiple times because we have a rental date and a return date. And both these aspects could be used to create dimension tables out of. Okay, so here's a quick recap of the most salient features of the denormalization of the old P schema from the Sakila database. Here you see that the address part from the Sakila database was a normalized structure with different tables, and we've denormalized it by taking the columns out of these tables and putting them into our dimension tables. And we're actually duplicating this data into the store and customer dimension. Another feature is where we took the categories, the many-to-many between film and categories, and what we did is we're actually making a repeating group out of these attributes and placing them into the film dimension table. Okay, so there are a few more concepts that come into play. There's the concept of the data mart, which is basically a selection of business processes that hang together, which would be interesting for one particular group of business users. And there's also, but basically this is the gist of the story. And what we want to do right now is I want to call for Matt Casters to demonstrate a few of the tools you can use to do this business intelligence. So.
Well, thank you, Roland. The whole thing, the dimensional modeling, is something that's very close to my heart, and that's why I always try to team up with Roland on these conferences to do this thing. Because if you look at business intelligence, it's usually something that's strategic to a certain business or an entity in the business. It's there to drive your sales or your growth, and it's not something that you can just try and no, you really have to do your best to make sure that all the questions from your customers, from your business users, are answered. In that respect, solving the problems that Roland just described, the whole transformation from a traditional form databases or a bunch of them into a dimensional model are not as trivial as you might think. There's a lot of data movement going on. Different types of databases are being read, different types of file systems, files. So typically what you end up with is some kind of tool that helps you do that. You can also script it, or and that's certainly how a lot of people used to do it. But the thing that I created something like 6, 7, 8 years ago, forgot, is a tool called Kettle, now Pentaho data integration. That helps you achieve your customers' goals, your corporate goals. So let's take a look. Typically what you see is a load strategy that goes something like this. We first load our dimensional tables. In this case, store, staff, customer, and film, and then we load our fact tables. In this case, we have one for the rentals. In case anything goes right at the end, we have a success mail that's being sent to our operators, and if something goes wrong, we send a mail to operators again, correct? All right. So let's take a quick look at, for example, the store dimension. What you're seeing here is the graphical user interface of Pentaho data integration. I'm doing another session tomorrow about Kettle, which is the name of the tool, and about Kettle, and also about cloud computing tomorrow at the same time in the neighborhood here. So as you can see, we're reading from the Sakila source database over here. You can just launch a SQL query. We get the store ID, the address ID, and an update field. And then we have like a lookup scenario that we put in a mapping for so that it's reusable. So we look up the address, we look up the city, we look up the country, and that's the part that we want to repeat because as Roland showed you, it's going to happen twice or three times in the warehouse. So yeah, we concatenate address lines, we clean it up a bit, and then we look up a store manager with a database lookup, and then we update what was called a slowly changing dimension. It's called slowly changing dimension because we want to keep all historical references, for example, a customer dimension or a store dimension. In this case, I think it's this label wrong. It's all right. So the store will slightly change, the definition of the store will slightly change over time. Maybe they moved across the street, maybe they switched to a different location. And if you want to then later on analyze how that store move affected your business. You might move to a busier location or to a less busy location. So if you want to see over time how that affected your business, then you better store both locations of the store. And this is done by a system of versioning in that dimension. You slowly change the dimension over time. That's why I call it slowly changing dimension. So basically what we offer our users of Kettle is a way to address what the natural key is of the store, in this case the store ID, and also which fields you want to keep historically, in this case all fields. Alright. So this is typically how a data integration, or also called ETL, extraction, transform, and load tool, looks like. Kettle is by far not the only tool on the market. There's like a really wide variety of commercial and open source tools. Incidentally, this one is open source LGPL license. So basically, what you do is you populate the dimensions one by one based on your business requirements. What am I going to look at? Here is the staff dimension. It's pretty much the same thing. Read the staff, select a couple of values. You do a little bit of cleanup. You try to make it as easy as possible for the end users or for your IT department to create reports. So if it says why, you might as well put yes in there or no, right? Just to make it easier for the eyes to look at the reports. Another one, maybe customers always, it's a good one. Active customers, yes or no. Important in this scenario is that you also try to adhere to certain standards, right? In a certain database, you might find yes and no. Another one, you might find 1 and 0, or Y and N, or active A and non-active N or something. In your warehouse, on your report, you just want to see a single, non-confusing set of options, set of definitions. And this is the sort of thing that you do in the ETL process as well. Clean up, standardize, go to a standard metric, standard set of colors, whatever. And this is how you do it. So just to go through this a little bit quicker, so the rental table, then the fact table itself, what it does, it actually just looks up keys to all these dimensions, and it tries to calculate, how many rentals there were. So in this case, it's always a 1 per fact. We also look up all these slowly changing dimensions, films. We look up dates and times. We calculate certain things. And in the end, what happens is that it gets stored in the fact rental table. And this is just a simple example of how you load the fact table. The result is more important now, right? Yeah. So once that is stored in the fact table and the dimensions are updated, we can do interesting things like create a BI report. And this is the Pentaho BI server that you're going to see here. I'll probably have to log in again or something. Let's see. What we're going to see here is a standard OLAP view. So it's online analytical processing. And basically what we did is we configured our OLAP server called Mondrian. Incidentally, if you want more information, the main author of the Mondrian OLAP server is also here today and tomorrow. Let me know if you're interested. So that server is going to cache all your queries concerning everything you want to know. For example, what kind of dates do I have? 2005, 2006. You can just drill down into the hierarchies that are refined, namely all dates, year, quarter, month. And then you can see the stores, for example. Why not Australia, Woodbridge. You can drill down into that, and then we can see, okay, there were 90 films there. What kind of films? English films, general audiences. You can see the whole thing. This sort of type of querying where you get the result immediately when you ask it is called OLAP. If it takes half an hour before you get the result back, or if it's less interactive, it's usually branded reporting, and in this case it's OLAP or analysis, which for short. A question?
Just one quick question. It seems like you were pretty much covered the counterparts, but I really appreciate that you just talked a little bit. So you had that GUI of the transformation.
Sure.
What happens with that after? So you've drawn these boxes and lines. What do those represent?
All right. So let's go back for a second. So there are two main aspects of loading a warehouse. The first is actually doing the work, reading from tables, doing lookups. And this is what we usually call, in our terminology, a transformation. And the individual pieces that you can see, table input, reading from a table, looking up things, selecting, calculating, those are called steps. And what we created here is a streaming engine that will flow the data from one step to the other, and it will follow the lines. There were buffers in between. There's like a whole technical explanation. Each of these steps will run in a separate thread, so it's like a multi-threaded application. And so the data gets enriched or modified or altered, transformed, and then loaded. This is the typical thing. Now, there can be a lot of things going wrong, right? Suppose your network connection is down, or suppose your server is down. That's why we created the concept of a job. And a job is basically a sequence of transformations or other job entries where we say, okay, if there's a green arrow, that means that the transformation here, dim store load, has completed successfully. Then you can go to the next one, dim stop. Then you can go to customer dimension, etc. So in this case, all the job entries are running in sequence, but only if the previous one was successful or not. You can also do an unconditional. And in this case, again, all the steps that are running here are running in parallel, which is a main difference in the approach. Now, obviously, Kettle has evolved a lot. It's not just for loading data warehouses anymore. For example, file management, we have things like copying files, FTPing things, waiting for a file to appear in a directory, emailing things, getting emails from a POP server. Maybe there are attachments that you get automatically. So it moves more and more into the realm of message passing, data migration exercises. There's a lot more to it than just the data warehousing aspect. But since these topics blend over, usually, that's to be accepted. Does that answer your question? Pretty much. Any other questions? I think we have one. Yes.
So, are you exporting these jobs, running from here? How do they execute?
Yes. So, so what we have here, as far as Kettle is concerned, is as far as the GUI is concerned, they're just definitions, right? Like you say, it's like GUIs. Actually, if you look at it, look at these files themselves. For example, a job. It's called a Kettle job file, KGB, but it's actually just XML, right? So there's no code being generated, no Perl, XML, no Java, or nothing being generated in back, no C code. What we have is an engine, so it's an engine-based approach. And what it will do is our engine will load that XML at runtime, that metadata, and then see, okay, I have to read data from a table here, I will have to execute this, and it will just do what you asked for it. So there are like 4 parts in our suite that we have. We have the Spoon GUI to enter the metadata, right? We have a tool called Pan to execute transformation. We have a tool called Kitchen. It's like in the food analogy. It was just a joke back then. It's kind of lame now. We have also these tools for batch execution. We also have a Carty server, which is like an embedded web server to do remote execution and clustering exercises. I will talk more about that tomorrow in the presentation. So basically, you just put your things in a cron job or in an ad job or in any kind of scheduler you want, and you just let it run every day. And we have all kinds of systems to do incremental updates to only get the changed data and stuff like that. But that will lead us too far, I think. Any other questions? So yeah. You want to close this? Yeah. All right.
So we looked at a few things. We looked at what is business intelligence. We looked at how does a data warehouse relate to business intelligence, what problems does it solve, what is the difference between a regular OLAP database like Sakila and the data warehouse counterpart. We looked a little bit at loading the data warehouse, and we looked a little bit at how to actually use the information we gathered in this way to provide a report, in this case this OLAP queue, which we could use to drill down and slice and dice our data. There's a lot more to it. We just, like I said, we just scratched the tip of the iceberg. Once you gathered a few of these reports and build them in your data warehouse, you can actually build charts, build reports, and gather them all together in a little dashboard. And there's one little thing I prepared the other day. I just want to see if I can get it to work for you. Just to give you another example of what you can do with this Pentaho solution. So what we have here is this is actually an example for another rental business. Oh, actually, I'm suffering from the demo effect. I'm sorry, I have to keep this for another time. But I just want to have one closing note, which is this. I'm in the process of creating a book together with my co-author Jos van Dongen, and this will be about data warehousing and BI using Pentaho and MySQL. It's a book which is focused on people that are perhaps not as familiar with data warehousing and BI, but do have some grip on MySQL. And on the other hand, we're targeting the business intelligence consultants, which are familiar with other products such as Business Objects or Microsoft BI. And we're telling them and learning them how to get started with Pentaho to build similar applications. So this book is now out. You can pre-order it on Amazon for $31, and it's going to be available on the shelves in August. It's going to be a 500 pages book. And if you have any questions about this, you can always email me at roland.bouman@gmail.com. And I'm sure that if you have any questions specifically about Cattle, Matt will be most willing to answer you those questions. Okay. Thank you. Thank you all for coming.